Howdy! This is my second balancing equation set. I'm doing 2 in one day, and I may or may not post these on 2 separate days. We'll just kind of see how things go. Again, please give me feedback so I know what this looks like and sounds like and what I can do to improve this. All right, we're going to do some more balancing equations using coefficients. And I'm going to continue to do them the way I've been doing them, where I list the elements out and how many of each kind. Okay, so we have a, this is called a single replacement reaction. Where magnesium takes the place of hydrogen, see that, and displaces hydrogen. So this is magnesium reacting with hydrochloric acid or hydrogen chloride to produce magnesium chloride and hydrogen gas. This is easily tested because, and I do this when we do labs, sadly we're not doing the labs, but you get to test for the presence. This makes heat and bubbles. This is a very exothermic reaction, and it produces hydrogen, which you can collect, and then you can test it using a match because hydrogen is very flammable gas. Okay. All right, and then in that process, when you add heat and oxygen, you make water. Yes. Okay. So let's see. This one's easy. Look at that. We just need a coefficient of 2 right here, and then we've got a balanced equation. You see that? 1 magnesium, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. All right. This is another example of a single replacement reaction. Chlorine reacts with potassium iodide to produce potassium chloride and iodine. It's a halogen that gets replaced. The chlorine replaces the iodine and kicks the iodine out. Oops, I'm going to keep them in the same order. Sorry. So I need to increase my chlorines, which increases my potassiums. And I need to increase my iodines and potassiums. Now we have a balanced equation. Ta-da! All right, let's do some more. Let's do some harder ones. How about these? Or do you want me to go back and do some more easy ones? I'll do some more easy ones. We'll do these 2 easy ones, and then we'll start with some harder ones. Okay, I really need to start doing some harder ones, because eventually you will have to do some harder ones. All right. Again, sodium reacts with hydrochloric acid to produce hydrogen and sodium chloride. This is an example of a single replacement. Sodium kicks out the hydrogen, makes hydrogen gas and a salt. All right. Let's see. What should we do? Any suggestions? I agree. Let's just do the 2. And then a 2, right? And then a 2. Yay! Good job. High five. Okay. Ooh, I just snorted. Sorry. All right. We got potassium. I'm going bonkers having to teach this way. This is not normal. All right. Potassium reacts with chlorine to produce potassium chloride. And you can probably see what needs to be done here right away. Got a 2, and then a 2. and balanced equation. Oh, I got the 2. Yay! Good job. High five. All right, let's do some harder ones. I might have to edit this video if I can't figure these out. All right, so we've got 1 iron, we've got iron 3 bromide, sulfuric acid. So see how this sulfate, like I showed you in the video before, is still present and didn't get broken up? Because sometimes they do get broken up. So I'm going to count that as 1. Ooh, I don't mean to write the 2 there like a subscript. So I'm going to count that as a 1 and just keep it together. All right? So the subscript around the parentheses tells me I have 3 of these guys. And if you have to, you can write them all out, you know, like SO4, 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 so you can see what you got. But if you broke them up and tried to balance the sulfurs and the oxygens, it takes longer. All right, so just try to train your brain into recognizing, you know, these polyatomic ions. So this is iron 3 bromide reacts with sulfuric acid to produce iron 2 sulfate and hydrobromic acid. Okay, this is a double displacement reaction where the bromine and the sulfate swap places. You see that? The bromine and the sulfate swap places? Okay. All right. So I definitely need 3 sulfates. If I did a coefficient of 3, that would go ahead and change my hydrogens. All right, and that's probably the easiest place to start. So if we try to make that a 3, I now have 6 hydrogens. Okay, so those are balanced. But if I come over here and do a 6, but yet I need 6 of these, so if I do a 2, I now have my 2. Ta-da! Do you see how I did that? If you need to, go back and replay and replay and replay. Let me know if I go too fast too. Okay? All right, let's do this one. Whoa, this was a hard one. Oh Lordy. Oh my goodness. And it's been so long since I've done. Let's see what this bad boy is. This is a methane, ethane, butane. Ethane? Oh, methane, ethane, butane. This is still 4. There's 3 oxygens. Ooh, I wonder what this is. I don't remember my organic chemistry. I'm off. We're going to go ahead and try this though. See if we can figure this out. Cho. Chaboogie. Okay. 4. 6 plus 2 is 8. 3 plus 1 is 4. Do you see that? 4. 6 plus 2 is 8. And 3 plus 1 is 4. Okay. Oh, well this is easy. We just need to do a 2. And then that brings up 4, 8, and 4. And we're done. Ta-da! Do you see that? Okay. I've done that one. That one's pretty easy. I'll skip those for now, okay? Here's some harder ones. Let's do some of these harder ones. All right. Carbon tetrafluoride reacts with bromine. And carbon tetrabromide or produced along with fluorine? Oh, that's easy too. Just need a coefficient of 2 there and a coefficient of 2 there, and we're done. Okay? All right, let's do this one. This is a combustion reaction. This was a single replacement reaction where fluorine and bromine swap places. This is methane, which comes from the decomposition of things that are organic, or from cows during their digestive process, or from the earth, where you find oil. This is natural gas. Okay? So combustion always is some carbon-hydrogen compound, reacts with oxygen, produce carbon dioxide and water. Okay. Joe. Two plus 1 is 3, and then 2. Let's see, a 2, because that gives us 4, and 2 plus 2 is 4, therefore, I made a funny, 4, therefore, okay. There's no one here to appreciate my corny humor. How's that? Is that okay? All right, let's do some harder ones. Ooh, I'm running at 11 minutes here. I'm going to do 2 more and then I'll call it a day. All right? What do we got? Sodium phosphate reacts with potassium hydroxide to make sodium hydroxide and potassium phosphate. This is an example of a double displacement reaction where the phosphate takes the place of the hydroxide. You see that? Okay. Oh, we're going to keep those phosphates together. Just have one of those. We've got 1 potassium. And then can you see that this hydroxide didn't turn into a water? So we're going to just keep it as, or oxygen, so we're going to keep the hydroxide together too. Makes it easier. So as long as you can see these polyatomic ions on both sides and they didn't break up and form something else, just count them as one thing together. Okay? Ooh, yeah, I have the 3 there. Okay. Whale. Whale, whale, whale. So let's do 3 sodiums, which gives us 3 hydroxides, which means over here we need 3 hydroxides and 3 potassiums, right? So we'll do a coefficient of 3. That was easy. Okie dokie artichoke. Alright, let's try this one. This is a weak base reacting with a strong acid to make a salt, which is just a form from a base and acid. Alright, so we've got ammonia reacts with sulfuric acid to make ammonium sulfate. Three plus 2 is 5, and we have 1 sulfate. And the sulfate didn't go anywhere. See, it's still together, so we're going to keep it together. And then, this does get a little tricky. All right, this makes a polyatomic ion, ammonium. You'll remember that from your polyatomic ion sheet, but we're going to break it up. Okay, we have 2 nitrogens. 2 times 4 is 8 hydrogens. Correct? Correct? And we still only have 1 sulfate. All right. Oh, this is tricky. Isn't that a song? Like something tricky, 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 something, I don't know. An old song, tricky, something. Okay, let's do 2 there, and then that's 6 plus 2 is 7, but we need 8. Oh, no, 6 plus 2 is 8. Oh, I can't do math. Oh, Lordy. Oh, goodness. Yeah, I'm rusty. 2 times 3 is 6, plus 2 is 8. We're balanced. It's done. Ta-da! Okay. And I'm at 15 minutes, so I'm going to stop for now. And let's see. I might do some more harder ones in a different set. See, I still got some more that I could do for you. Okay? All right. Bye.